Section 3 of Chapter 2 is on the multiplication principle of equality. And if you will remember, the last section we did the addition property of equality, and that meant that we could add or subtract anything with an equation as long as we did the same thing to both sides. So, wonder of wonders, the multiplication principle of equality is going to say that we can multiply an equation by anything that we want to as long as we multiply the same thing on both sides. We've got to keep that balance equal because it is an equation. So let's just jump right in and start solving some. If you've got negative 56 equals a negative 7 times t, well, I said you can multiply by anything. You can also divide by anything. So this is negative 7 times some number. And so because they multiplied it, to undo it, you're going to divide. And what you'll do is you'll divide by that negative 7 because the whole point is you want to be able to reduce that down to just t. And that's fine. You can do that as long as you do the same thing to both sides. So divide negative 56 by negative 7. And so now t equals 8. And you'll notice that I flipped it just so that it looks like what we normally see. The original equation was 8 equals t, but t equals 8 is the same thing. Now, if we are multiplying by a fraction, this one is actually multiplied by a whole number, but we could say that was 7 over 1. This one is multiplied by a fraction with a numerator and a denominator. Do you remember that when you divide, you actually multiply by the reciprocal? The reason is this. If you multiply this by a negative 5 over 4, if you multiply this 4/5 times 5 over 4, your 5's will reduce down to just 1 and your 4's will reduce down to just 1. Negative times a negative is a positive and you are left with just m, which is what you want. So the reciprocal of a number is its opposite. And so by multiplying by its reciprocal, you get the answer of just 1. So because we multiplied on this side by negative 5/4, we've got to multiply on this side by negative 5 over 4. And so here we just multiply. You can multiply straight across and then reduce. I prefer to reduce first because you're dealing with smaller numbers. So 7 and 5 won't reduce because they're both prime, but 6 and 4 is 2 times 2, and 6 is 2 times 3. So those 2's will reduce, leaving you with just 3 in the numerator and 2 in the denominator. So then you multiply straight across with what's left. So 3 times 5 is 15. And 7 times 2 is 14. Now you had a positive times a negative, so don't lose. You have a positive times a negative. Your answer is a negative 15/14. Don't lose your negative. All right. So then once we know that, well, now we can do both. We can add or subtract and we can multiply or divide. We can do that within the same problem. So here, the trick is to look at a problem and decide, well, what was done to this x? And then you've got to undo it backwards. So they multiplied, because of the order of operations, they multiplied first and then they subtracted. So to undo, you're going to do the order of operations backwards. So they subtracted last, so you're going to undo that subtraction first. So you're going to add 11 to both sides and get negative 3x equals 17, 18. And because this is multiplying, you're going to divide to undo it. So divide by negative 3 so that reduces down. And divide this by negative 3. And so x equals 18 divided by 3 is 6. Positive divided by a negative is a negative 6. Okay, the next step says, okay, all terms with a variable have to be together. In this problem, you'll notice you have y's on this side and this side of the equation. And you've got to get them together. And it's tempting to just say, I have 8 here and 2 here, so I have 10, right? You don't, because they're on opposite sides of that equation. So they're on separate sides of your balance scale. So to move one to the other side, you're going to have to use your properties. And so what you can do is you can subtract it. You can take it off of this side of the balance and put it on the other side. So you can subtract 2y for, I said 2 and I wrote 3. That's pretty crazy. Subtract 2y. And if you do that, remember you've got to do, the same thing to both sides. So what I would do is I would put it right under the other y term here. So now these drop out, and so then the 8 minus 2 is, you've got 6y now, and the rest is the same. So now this is a problem that looks just like this. So the subtracting 5 came last, so you're going to add 5 to get it to the other side. And so negative 29 is going to be negative 24 now, right? Yes. And then 6y equals negative 24 multiplied, so you're going to divide to undo. So you have to divide, same thing on both sides. And negative divided by a positive is a negative, so y equals negative 4. All right, this is too easy. Let's make it harder. All right, so when you're doing this, when you're solving these, you've got to make sure that you simplify as far as you can before you start trying to manipulate the numbers. So let's look at one that's just a little bit more complex. What about 17 minus 4n minus 5? That's a quantity, equals 9n minus 3 times the quantity of n plus 7. All right, before you can start solving, and I'm going to write, while I'm in the writing mode, I'll write this one up here too. Okay, all right, so while you're solving this, before you can solve, before you can start putting those variables together, you've got to get rid of the parentheses and start simplifying things. So in order to get rid of these parentheses, you're going to multiply what's in front of it by the whole thing. And this negative is like a negative 1. So you're going to multiply the negative 1 all the way through. Be really careful with negatives. It's really easy just to ignore them and just to say, well, this is 17 minus 4n minus 5. Well, it is 17 minus 4n, but this negative 1 also has to be multiplied by the negative 5, and a negative of a negative is a positive. All right, equals 9n, and now we've got to multiply the negative 3 all the way through. So negative 3n, negative 3 times a positive 7 is negative 21. Are you doing this while I'm doing this? I sure hope so. I'm not doing this for you just to watch. Be putting it on your paper so you have an example to follow. Okay, so now the next thing is to start on either side of the equation, simplify what you've got. So you've got two terms that are constants and one that's a variable. So put your constants together. 17 plus 5 is, what is that? 17, 18, 20, 22. Minus 4n equals 9 minus 3 is 6n minus 21. Now we can start putting the, now all we have is a constant term and a variable on each side. So now we can start putting them together on the same side of the equation. What I like to do is keep my variable term positive. And so because this one is a negative, if I add 4 to both sides, add the 4n, that keeps my variable positive. So now I have 10n on this side. And then at the same time you can say, well, if I'm going to move the n's to this side, I want to move the constants to the other side. So I'm going to add 21 to both sides here. So now it's 43. So 43 equals 10n. And it's going to look messy, but it's really okay, all right? So you're going to divide by 10 on both sides, and so your final answer is just 43 tenths. If you happen to put it into your calculator and you get 4.3, that's all right too. So 43 tenths equals n is your final answer. All right, on one that looks like this, we've got fractions, and everybody goes, oh no, fractions. Well, guess what? Let's just get rid of them. Here's how we're going to do that. If you'll look at your denominators and find your least common denominator. We did that when we tried to get like denominators to add. So here's a trick though. If you can get your common denominator, you've got 3, 4, and 6. Well, 3 times 4 is 12, and 6 times 2 is 12. So I'm going to use 12 as my common denominator. And if I multiply everything in the entire equation by 12, then I haven't changed anything. As long as I multiply everything by 12, I haven't changed the value of the equation. So let's do that and watch what happens. Because I'm multiplying by a multiple of these denominators, what's going to happen is this. This 3 will reduce, and the 12 will reduce to a 4. So now I have 4x. And here the 4 will reduce, and the numerator will reduce to a 3. So now I have 3 times 3 is 9. Catch what I'm doing? So now I'm going to multiply this fraction by 12. The 6 reduces, and the 12 reduces down to 2. So now 5 times 2 is 10x. And the 2 doesn't have a denominator, so you just have to multiply the 2 times 2 is 24. 2 times 12 is 24. All right, so now you have an equation that looks like this step. And so now it's the same thing we just did. Let's put everything together. The 4 is smaller than the 10, so let's move it to that side so we keep it positive. So we have 6x, and we're going to subtract 24. And negative 24 and negative 9 is negative 33 equals 6x. So now I'm going to divide by 6 on both sides. So my x is 33 over 6. I can reduce it by 3. So a negative 11 halves. All right, one more type and then a word problem. You can do this. So the next thing we're going to do is, so far what we've got to do, we've got to simplify as far as we can. And if you've got fractions, you want to multiply by the least common denominator so you can get rid of those fractions. We can do the same kind of idea with decimals. Here we go. If you've got 0.2 times the quantity y minus 6 equals, oh, guess what? I don't know what my original problem is. Oh, there we go. There it is. 0.48y plus 3. There it is. Okay. So what you're going to do with this is what you need to do first is get rid of the parentheses. All right? So just like we did before, get rid of the parentheses. So 0.2y minus 0.2 times 6 is going to be 2 times 6 is 12 with one decimal point. So 1.2. And that's going to equal 0.48y plus 3. Now, here's the trick with this. Remember, you can multiply by anything you want to. If I multiply this decimal, this is the one with the most decimal places. If I multiply this decimal times 100, that's going to move my decimal over to the end. And then I won't have a decimal to mess with, which kind of neatens things up for figuring. So what I want to do is I want to multiply by a power of 10 that will move the decimal to the end of every number in my problem. So in this case, I'm multiplying by 100. You can also think of it as, if you're multiplying by a power of 10, you're just moving that decimal the same number of places as zeros that you have. So in this case, I'm just going to move this one 2 places and have 20y. You're going to move this one 2 places and have 120. Move this one 2 places, 48y plus 300. And now you've got just what you had before. Let's see. This time, let's do it this way. Let's add 120 and get 420. And then, so now we have to move the y's over this way. So minus 48y is going to be a negative 28y equals 420. And when we divide both sides by 420, and make sure by 28, sorry. Divide both sides by negative 28. We should get 15, I believe. Yes. So now y equals negative 15 because you got a positive divided by a negative. And we didn't have to deal with all the decimals. So move the decimals in everything. Make sure that everything in the entire equation, the decimal gets moved the same number of places, and you haven't changed the value. All right, last thing. Because you knew you weren't going to get away without doing a word problem. Here we go. The perimeter of this shape is 188. The perimeter, remember, is the rim. It's the outside edges. So we're putting crown molding around something or a fence around something. That's the perimeter. So the perimeter is 188, and we want to know the width and the length. So you have to remember the formula for perimeter. Perimeter is 2 times the length plus 2 times the width, because you have to have 2 of these and 2 of those, right? So that's fine and dandy, except I've got all of these letters. So let's replace as many as we can. If we have just one letter, then we can solve for it. One variable we can solve for. So we know the perimeter is 188, so we can put that in for P. Perimeter equals 2 times the length. What's the length? Well, in this case, the length is W plus 7. So put that in. Plus 2 times the width, and in this case, the width is still just W. So now we simply solve. So don't forget, we've got to simplify as far as we can. So 188 is going to equal 2W plus 14 plus 2W. Combine these like terms. So 188 equals 4W plus 14. Subtract the 14 from both sides. And that is 174 equals 4W. Divide both sides by 4. And what is that? Let's see. That's going to be 4 times 4 is 16. 4 times, yes, 40. Oh, 16, 17. Did I work it out on here? Oh, I did. I worked it out because it doesn't come out evenly. Here we go. 43.5 is W. And so if the width is 43.5, and we got to put feet on here. So 43.5 is our width. And so our length, remember, is going to be W plus 7. So you add 7 to that, and so you have 50.5 feet is the length. All right, so the trick with that is just you've got to start out with what formula am I going to use, and then just plug in the pieces that you know from the problem that you're given. You can do this. All right, see you soon.